Supernova and stellar death. Supernova are one of the most energetic and dramatic events in the universe, occurring when a massive star reaches the end of its life cycle and undergoes a catastrophic explosion. This explosion releases an enormous amount of energy and matter, which can be seen across vast distances in the universe. The process of a star's death and eventual supernova is complex and depends on its mass, age, and composition. However, we can broadly divide the process into two main stages: the death of the star's core and the explosion that follows. The death of the star's core. All stars, regardless of their mass, eventually run out of fuel to burn in their cores. In normal stars like the Sun, this causes the core to collapse, which leads to the outer layers of the star expanding and eventually becoming a red giant. However, in more massive stars, the core collapse can be much more catastrophic. When the core of a massive star runs out of fuel, it can no longer generate enough heat and pressure to counteract the inward pull of gravity. This causes the core to collapse under its own weight, which releases an enormous amount of gravitational potential energy. As the core collapses, the temperature and density increase dramatically, and the electrons and protons in the core merge to form neutrons and neutrinos. This process is known as neutronization, and it releases a large amount of energy in the form of neutrinos. These neutrinos are extremely difficult to detect, but they carry away a significant amount of the energy released during a supernova. As the core continues to collapse, it eventually reaches a point where the density becomes so high that the neutrons themselves start to merge together. This process, known as neutron degeneracy, causes the core to become incredibly dense and compact, with a mass several times that of the Sun, but a size no larger than a city. At this point, the core is essentially a giant ball of neutrons, known as a neutron star. The neutron star is held up by the neutron degeneracy pressure, which counteracts the inward pull of gravity. The formation of a neutron star is not the end of the story, however. The outer layers of the star are still hurtling towards the core, and when they reach it, they bounce off the incredibly dense neutron star and explode outwards. This explosion is what we observe as a supernova. The explosion is caused by a combination of several factors, including the energy released during the core collapse, the rebound of the outer layers off the neutron star, and the shockwave created by the explosion itself. The shockwave heats up the outer layers of the star, causing them to glow brightly and release an enormous amount of energy. The explosion also releases a large amount of heavy elements, such as gold, silver, and uranium, into the surrounding space. These elements are created during the supernova through a process known as nucleosynthesis, which involves the fusion of atomic nuclei. The energy released during a supernova is so great that it can briefly outshine entire galaxies, and the explosion itself can be visible from across the universe. The remnants of supernova can also be seen as beautiful and complex structures, such as the Crab Nebula and the Cassiopeia, a supernova remnant. In conclusion, supernova are incredibly complex and dramatic events that mark the end of a massive star's life. They are also incredibly important for the creation of heavy elements in the universe, and they play a critical role in shaping the structure of galaxies and the evolution of the universe as a whole.